So in this section, it's pretty much the same as the sections before. We're just going to, again, spend a whole section on integral, but this time we're going to focus on particle motions or just motions in general. And the handout that I give you was actually a copy from the book. It basically kind of helps you translate word problems into integral or derivative properties that you're looking for. So you should use that for the time being of checking out how to translate a word problem for now, but eventually you want to memorize it so that you don't need that cheat sheet. Okay, so let's take a look at this problem. A particle moves along a horizontal line. For 0 less than t less than 8, the velocity of the particle is given by this function, and the position is given by s of t. It is known that s of 0 is equal to negative 3. You always want to be aware that there is an initial condition. A, find all values of t in the interval 4 to 7, for which the speed of the particle is 5. Okay, so this problem is a little bit tricky because it's asking for the speed equal to 5. Remember, speed is a scalar term. It is not a vector. Therefore, we want to figure out the absolute value of t equal to 5. So basically it's saying that even if it's minus 5, we want to figure out when that happens. And now, sorry about that, I realized that I wrote the wrong equation. It's not the exact same equation as the book, so I'm going to change it right now so it matches the book. So you can double check your answer against the book if you want to. Okay, so basically what we're trying to do is figure out when is absolute value of v equal to 5. Now recall in algebra 2, when you have an absolute value of a function, it is the same as the function being a positive and the function being a negative. So it depends on how you want to solve the problem. I would like to just graph one thing and figure out where that intersects against the x-axis instead of graphing two things, because recall that in algebra 2 we talked about we can graph this one, we can graph this one and see where they intersect. So basically you're graphing y equals v and y equals 5 and then see where that intersects. I don't like doing that because your y equals 5 may be very high or maybe somewhere else that you may not see. It's easier if you just graph everything where you're seeing what crosses the x-axis. So what I would like to do is change this question so that it is v of t minus 5 equals 0. And then so you're graphing this part and trying to see where that crosses the x-axis. Okay, so when you do that, t is equal to 6.520. I believe this has no unit, so no s. Okay, and then same thing here. V of t plus 5 equals 0. And then check what that time is. Time is 5.621. Of course, I believe this one is going to intersect in more areas than this one, but recall that the interval is from 4 to 7. So you're only looking at numbers that work from 4 to 7. Okay, so that is part A. The tricky part again of part A is speed. It's not asking when velocity is 5. It's asking when speed is 5. That means you have positive and negative. Okay, B. Write an expression. So expression means don't solve. Involving an integral that gives the position s. And then they do want you to solve. Use this expression to find the position of the particle at time equals 3. Okay, so any position is going to be equal to the initial position plus the change. So this is kind of, 2 sections ago when we were talking about accumulation function and basically saying um, the FTC part 2 applies where the integral, meaning the net change, is equal to the final minus the initial. So then you kind of manipulate that whole thing around, and then S of t is equal to the initial plus the integral, which means the net change from 0 to t, whenever t is, of v of t dt. Okay, and since they do give us an initial condition, we want to put that into our function. The initial condition is at 0, it is negative 3. So this is negative 3 plus integral from 0 to t v of t dt. Okay, so that is the first part. Please make sure when you're reading a question, you answer every part of the problem. Some of you, spend a lot of time answering just the first part, but you skip whatever else there is. So please be careful. They want you to actually figure out what it is at 3. So S of 3 is equal to negative 3 plus the integral from 0 to 3 v of t dt. Again, just use your calculator to figure out that answer. This is negative 6.263. Okay, next one. Find all times t in the interval 0 to 8 at which the particle changes direction. Particle changes direction. So if you forgot what that means, again, use the cheat sheet to help you. Changes direction means that v of t has to be 0 at that point. Not only so, it has to change direction. It can't just stop and then go back to, continue going in the same direction. Like it momentarily stopped. Like, let's say that something was falling and it stopped for a sec or at that moment and it continues falling. It didn't change direction. It continued going in same direction. So that would not work. So what you have to do is figure out when is v 0. That's where it stops. The second thing that has to happen is it has to change direction, which means that it has to change from positive to negative or negative to positive, but it has to change direction, which means you need to first figure out when it's 0 on the graph, and then you need to make a sign chart. So set v of t equal to 0. This is going to give you 2 numbers within 0 to 8. So 2.341 and 6.127. Okay, from the graph, you can see that less than, so we are looking for from the interval between 0 to 8. So between 0 to 2.341, that is negative. Between 2.341 to 6.127, that is positive. And then between 6.127 to 8 is negative. So it is actually changing directions on all these points that make velocity 0. So t is equal to 2.341 and 6.127. Okay, last question. Is the speed of the particle increasing or decreasing at time t equals 7? Okay, so I feel like our class is not being tricked by this question anymore. So is the speed increasing or decreasing? Again, speed is a scalar term. So that just means is velocity and acceleration going in the same direction or not? Meaning, is v of 7 and a of 7 both increasing, both positive or both negative? Okay, so all you have to do is just plug it into the calculator and see what kind of sign you get. When v is at t equals 7, it is negative, and a at t equals 7 is also negative. That means the speed is increasing at t equals 7 because v of 7 and a of 7 have same signs. Please be careful on your justification. Please don't say they are both increasing. Not true. V of t increasing means you're looking at the acceleration. So it's not exactly the same. Same signs means is it above the axis? Is it below the axis? Increasing means is it going up or is it going down? Okay, so you can have a graph that is positive but going down. So that is not the same question. Okay, I realized I didn't justify for C. Okay, justify your answer. How did you know that this particle changes direction at t equals these two numbers? So you would say, the particle changes direction at t equals 2.341 and 6.127 because v of t changes signs. Again, please don't write changes direction at these two values. Double check, we don't need to justify anything else. Okay, so we're good. Okay, next question. The velocity of the Space Shot amusement park ride for t between 0 to 14 is modeled by a piecewise linear function shown below, where t is measured in seconds and v in feet per second. Okay, look at part A. At what times in the interval from 0 to 14, if any, does the space shot change direction? Give a reason for your answer. Okay, so we just did something like this. Change direction means v of t equals 0 and it has to change size. Okay, so the easiest thing to do is, since they already give you a graph of v, you want to just look at where it is 0. Okay, 0 is 0. 6, 8, 10, 14. Okay, now look at the sign chart. This is positive, negative, positive, negative. It has to change sign. That means the endpoints don't count because you don't know what is beyond the endpoint. So t equals 6, 8, 10 because v of t changes signs on those points. Okay, so that is pretty easy because we just did something like that. Next, at what time in the interval 0 to 14 is the space shot highest? How high is the ride at a time? All right, so this is the question where you have to kind of be careful. At what time is the space shot the highest? Highest has to do with distance. So basically, when is the, so you're going to try to translate this. What does highest mean? Highest distance means S of t is absolute max. So if you kind of translate into calculus terms, it's easier to figure out what you need to do next. So basically, it's a question about absolute max. Absolute max has to do with derivative. So when is the derivative 0 and the sign has to change from positive to negative? That would give us a relative max, but this wants a highest, which means absolute max. So we need to double check the endpoints. All right, so from part A, you can see that there are two candidates, 6 or 10. So we need to figure out what is the distance at 6 and what is the position at 6 and what is the position at 10. And also we need to check the endpoints, which is 0 and 14. Okay, from this graph, this is a velocity graph. What we want to do is find the position, which is the area under the curve. All right, so S of 6. S of 6 is this whole area underneath. Now, please be careful because this increment is 20 and not 1. So when you do find the area, you have to make sure you multiply by the correct increment. Okay, so find the area underneath the curve between 0 to 6. And also double check to see if there are any initial position, which one this one doesn't. So we can just be sure to find the area underneath the curve and then we're pretty much done. Okay, so S of 6 is equal to 100. S of 10, okay, S of 10 is this part minus this part because we're now talking about position, so the area beneath the curve is negative, and then add this part. So S of 10 is 80. S of 0 is 0 because it doesn't tell us that there is initial position, so we're assuming that it just started at 0. S of 14 is also 0 because it actually did just go back to its initial position. So that's that. We don't need to check S of 8 because that is a relative min, so that is not going to be a highest number at all. Okay, so based on these numbers, you can see when it is highest. So you would say it is highest at t equals 6, and it is what is this? I don't think it gave us a it doesn't give us a unit, so it is 100 at t equals 6. Okay, C. Find the total distance. All right, so this one, again, be careful. Total distance has to do with the absolute value of position. So we are, no matter if it's a negative position or positive position, we're going to count it all as positive. So basically, it's the total area underneath the curve, but this time we are going to add up all of the numbers. So if it's below the curve, we are also going to count it as positive because it's a distance traveled. Okay, so basically add up all the area. The total distance is 280. Last one. Write expressions for the right acceleration a of t, v of t, and distance s of t from the ground that are valid for the time travel 10 to 12. Okay, so looking at this graph, obviously we cannot write a function for the whole thing. I mean, you could, it's all going to be piecewise. So that's why the question wanted you to just focus on 10 to 12, which is this line segment. So basically they want you to write a equation for this line. Now, and then they want you to do that for V, A, and S. Since they give you the graph for V, it's much easier if you just start in V. So looking at this graph, you need to write an equation for this line segment. Now just recall Algebra 1. Find the 2 points on this line. So this is 12, negative 40, and this is 10, 0. So basically write an equation that goes through these 2 points. Okay, so slope is equal to, okay, let me write down those 2 points just in case. 10, 0, and 12, negative 40. So the slope is negative 40 minus 0 over 12 minus 10, which is negative 40 over 2, which is negative 20. So slope is going down. Okay. Now, because anyways, so just now write the equation of the line. So y minus 0 is equal to negative 20 times x minus 10. So then y is equal to negative 20x plus 200. We're multiplying it all out. For this case, usually, I tell you to leave it in point slope form. But since this time we are looking for the velocity, and from there we're going to integrate to figure out the position, we have to multiply it out. It's easier to integrate that way. Okay, so this y, what does y mean? Y means velocity, because that was the equation of the velocity curve. Okay, so we found this. V of t is equal to negative 20x, sorry, I should write this in t, 20t plus 200. The easy one is to find a, which is negative 20. Just take the derivative, which you can also see that it is just the slope, which makes sense anyways. Okay, s of t is a little bit tricky. S of t, what you're going to do is integrate. So let me write that here. S of t is equal to the integral of v of t dt. So when you integrate that, remember that you're taking a antiderivative of this function, which means there's going to be a c involved. Please be careful and do find c. Okay, this is going to be negative 10t squared plus 200t plus c. The question is, what is c? Is there an initial condition involved? Well, there is. Although there is nothing at s of 0, we are writing an equation that only applies to 10 to 12, which means we need to take the initial condition that is given in s of 10 or s of 12, whichever number you have. Now go back to the question. We did find s of 10. S of 10 is 80. So that means there is an initial condition, or there is not an initial condition, but there's a condition at 10. S of 10 that says as position 10, it is 80. So this is equal to 80. So then plug that in. Negative 10 times 10 squared plus 200 times 10 plus c. From here, we want to figure out c. And in this case, c is minus 920. Okay, so that gives us the third equation. S of t is equal to negative 10t squared plus 200t minus 920. Okay, there are our three equations.